creating the condition. So remember, we're going to be going through a cycloid, so let us see if we can go about creating the condition. Now we're going to be using that as our center line. And if I get my compass right here, then I need a circle that will be rolling. Now let us create a condition. So we now have our circle. We have the center line for our circle. And we have our tract that is right here. Now, as you know, we're going to divide our circle into 12 equal parts. So we know how to divide our circles. We can actually use our compass in dividing our circle, or another method is that we could actually use our 60-30 degrees set squared in dividing our circles. Now when we divide our circle into the 12 equal parts, then we're going to be going about creating a condition for the cycloid. Remember, I have to come in a little bit more to pay attention to the details. Let me get a different color because we're going to be highlighting now a few things. We're going to be using green. Now let us see if we can use this green to highlight the point that we're going to be tracing. So this is going to be point P. So we're going to be tracing point P as it makes one complete revolution. Now let us see if we can label our drawing. So we have P here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have our 12 equal divisions. Now from there, if I use my blue, then we're going to be bringing across these necessary right division points. So we're going to be bringing across our 1 and our 11, or 2 and 10 will share the same line. 2 and 10 will share the same line. 3, 9, as well as the center point that is right here, shares that white line. 4 and 8 will have its unique line. 5 and 7 will have its line. And then 6, we know 6 will have its line. So you notice that this is the path that this wheel or this circle is going to be traversing as it rolls along. Now another important point is for us to actually identify the span that the circle will be rolling. Now if we go across here and we get one of our divisions, which is going to be 0 to 1, and we are going to now take out those divisions. So that will be 1, 2, 3, 4, 5, 6. So I'm going to be doing the first 6 divisions. Because remember that at 6, we know that the track breaks at a 45-degree angle. At 6, the track breaks at a 45-degree angle. Now, if we just put our little break right there, this is our 45 degrees set square. So at 6, the track is broken right here. Yes, so you know this, that will represent our 45 degrees. But let us see if we can actually go through, 0 to 6 first. So we're going to be going through 0 to 6 first. to get, you know, the first half of the circumference of our circle. So we're going to turn up these vertical lines. Now, just to be clear with our drawing, let us continue with our numbering. So remember, from here to here, we have 1, 2, 3, 4, 5, and 6. 6 is where our track is broken. Now we're going to be carrying some vertical lines up. So at 1, we're going to be having a vertical line right here at 1. Now, of course, with our cycloid, it's a lot of lines. Now I use different colors so as to make our drawing as clear as possible, so that all of you at home will be able to follow clearly what is going on. Alright, so this would have easily now satisfied a few of our conditions that we have outlined. So we have our 0, 1, 2, 3, 4, 5, 6, and we have our P. So we're going to be plotting our point P as it makes, you know, half the circumference in terms of rotating. Now we will now need to get back, you know, the radius of our circle. So this is our circle. This is the radius of our circle. The radius of our circle, you know, cannot change. Now if I move to 1, so my circle rolls, and the center of my circle moves up here, and it now is right there sitting at 1. So if it is sitting right there at 1, if I should redraw my circle right here, then where would my P move to? That is the important question. Where would my P move to? So my P, my point right here, is going to be moving, and this is a 1 line. So let me get a different color. So let's be using green. So my P will be moving right here to where that 1 line is. So it moves from 0. So my center is now at 1. And then now we're going to be plotting the 1 as it makes one complete revolution. So my P will be moving to right there. Now if I move to 2, then pretty much is right here. And if I cut the 2 line, my P will move now to right here, which is now my 2 line. 3, this is now my center 3. And if I move from 3 and cut the 3, my P will now move to the 3 line right there. 4, this is my center 4. So this will be where my 4 line is. So 4 and 8 share the same line. 5, this is my center 5. And then this is where my 5 line is. So 5 and 7 share the same line. And even without even drawing 6, we know that 6 will top off right here at the top. So this circle that we originally had here, which is P, we're plotting the point P. By the time the center moves here, without sliding or slipping on this straight path, then my P would have gone through all of these points, reaching up to its top right here. Now it's a freehand curve. Remember, as we mentioned, ladies and gentlemen, when you're doing your freehand curve, then you don't want to stop in the hole. So that is my freehand curve, you know, tracing the point of P as it makes half the, you know, circumference. So I have to rotate half the circumference of the circle. Pause. Alright, so now we're going to be focusing now on our 45-degree break. Now this is the part that is confusing to a few. Not going to say the many or the majority, just a few. This part is a little bit confusing, you know, for me. Now I'm going to be getting rid of some of my excess lines so as to not make the drawing confusing. Now we have our 45-degree break right here. Now I can go and extend my 45-degree break. So if I use this white chalk right here, and actually extend my track. So that is now my track being extended. That is now 45 degrees. Now what happens when the circle comes right here? When the circle comes right here, what happens? Then the circle is actually going to be going downhill, rolling downhill, so to speak. Now there are a few things that did not change. For one, the radius of the circle did not change. So the circle, the radius of the circle, whatever it is, it did not change. So we can understand that when the circle reaches right here and it starts to roll down, the same measurements that we have up here would be the same measurements that we would have going down as well. Now let us see if we can actually satisfy that. So what we would need right here is actually a 90 degree. So if this is 45 degree, then if you turn it the other way, you notice that what we get right here is a 90 degree angle. Now, what I'm going to be doing is that I'm going to be transposing some of my lines, so to speak. So we're going to be taking across some of our lines. So right here is where our little pivot will be. Now if I should bring across my center line, notice I just brought across my center line. And let us see if I can just bring across these lines that I have up here. Bring across that one. I'm going to also bring across that one. And then now, this is my circle. You notice? Bring across that one as well. And same thing that will happen right here. Bring across that one. And then right here, bring across that one. Now, my points have been come across. And I'm also going to ensure that everything is also going to be vertical. So I will bring slight line 6 through here. So this, what we have over here is almost, we have a true reflection of what is happening over there as well. Now let us see if we can actually tidy up some aspects of our drawing. Now a key point to make note of is that when we trace the point, we were actually half the circumference of the circle. And we had 6 having the highest point here. Right there. Now you notice that as 6 has 2 points. So we have 6 having a vertical here to correspond with this side. And we also have 0.6 having another vertical here to correspond with this side. So you notice that this would also be the point of our circle there at 6. And then of course we will need to highlight this line. Well, these things do happen. So no need to worry. So we need to highlight this point as it continues to make its rotation without slipping or sliding. Alright? So where would be my 7 points? So if we go back to our drawing and we take off our division, so this would be one of our division right here from 0 to 1, and go to 6, then that would be be 7, 8, 9, 10, 11, and 12. So that is where we will actually get our additional divisions. So this will now be 7, 8, 9, 10, 11, and 12. Now, just as what we did earlier, we will need our vertical. So we will now continue by getting our vertical. So we need another vertical here, which will be perpendicular to the baseline. That will be 7. Same thing for 8. Perpendicular to the baseline. Same thing will be true for 9. Perpendicular to the baseline. Then we need to get the same thing happening for 10. And then 11. And 12. Alright. 11 and 12. So let me just clean up these lines. Alright. So that's what we have right there. So we have our 7, or 8, or 9, 10, 11, and 12. Now if we get back to our drawing, and we actually get the radius of our circle. So this is actually the radius of our circle. And we come to our center right here. You notice that it actually coincides with what we have right there. Alright. So let me see if I can sharpen my sharpen the chalk. And let us see if we can just get rid of some of these excess lines. We're going to now go back through our habit. So let us repeat that step. So we actually have the radius here, and having had the radius there, then at this point, so you notice that would be 7. So 7, because this is 7, so 7 will start right here, and 7 comes right across, so this will be 7 right here. Then if we go to 8, so 8 will be on this line, and 8 will come right here. And that means then 9. So 9 is on this line with our center, so 9 will be right here. And then 10. So 10 will be sharing this line right here. How we know? Because when they come across, 10 and 2 share the same line. Then we have 11. So this will be 11 right here. And then of course we know that our 12 would be right there. Alright? So that would be our 12 sitting right there. So we can easily now continue to trace the path that our point would make, as it makes 1, complete revolution without slipping or skidding. So this is what our cycloid will look like when it actually has a break in the track. And as we mentioned to you students, that it is important that what is in green would be brightened, and it is also important that we also highlight our track. Now we're not going to be making it as bright as what green would be, but our track would be, highlighted so that we have, it is widely known as the path that our circle was traversing. Alright? Now you already have the question for this drawing, and I have now worked out or shown you how to go about following the steps and procedures for this drawing. But let us recap. We know how to get our cycloid up to 0.6. So right at where 6 is where the confusion comes in. So simply put, students, we're going to be, it is a 45-degree break. So remember, just as we have our vertical lines here, we still need our vertical lines, perpendicular lines to our track. So nothing to worry about. The only thing about it is that when you get your perpendicular line at 6, for the 45-degree break, then all you actually need to do is also bring across those lines. So I just use my compass, bring across the lines, bring across the lines. And by doing that, then I'll be able to get the downward, trajectory for our other lines. Now, if you have any questions, you can reach out to me on WhatsApp. Now, I expect all students to actually complete this drawing, and I expect to have them, by Wednesday. We have class on Wednesday, so I expect to have these drawings by Wednesday, the latest, in my inbox for me to mark them. So I expect you to take a clear picture highlighting all the steps that they have just gone through. So thanks again, keep safe, one love.